Hello students, I am Gerard from Pixel Computer Tutorial. We will be learning about evolution of computers. So this is the first page we will be starting off. So as in with this, the first paragraph, learning scope. The evolution of computers started way back in the late 1930s, and the first known device was called abacus. Based on the hardware, evolution of the computer has been classified into 5 generations. So we will see the generations one after the other. Now let us understand what is abacus is all about. Okay, so initially in the year 4000 BC, people did have a concept of counting numbers, and they had the counting system. But during that time, they didn't have any kind of a particular pattern. They followed using pebbles, fingers, toes, even bones also to count numbers. Same way, as we go to the next paragraph, it was that time they initially developed an concept called as abacus. This abacus is, or rather was, invented by Egyptians and later developed by Chinese and Japanese. Abacus is being used since 450 BC. Even today, the concept of abacus is being used in pre-nursery, nurseries classes to give you the fundamental ideas of counting, and how to understand what is numbers and how it is counted. Okay, now let us look at the mechanism of abacus. Basically, the abacus is a calculating machine. First understand that it is a calculating machine, comprises of a rectangular wooden frame on which vertical rods are fixed. These rods contain beads. So when I'm talking about the beads, these are the beads which I'm talking about. These are the beads, and this is the rod, and there are 2 beads on the top, and there are 5 beads at the bottom. Okay, so it is a sequence of beads here and a sequence on the top, that is the upper beads and the lower beads here. Okay, alright. Now the upper beads were called as heaven and the lower beads were called as earth. Okay, the upper beads had 2 and the lower beads had 5. Okay, right. Now when we bring these beads to the divider, this is the divider. See, you see the line here, this is the divider. Okay, this is the divider. So when you bring these beads, one here and one here, so as one down and one or 2 or 3 or 5, depending on the numbers or the counts you want. Okay, the value keeps changing. Right now all the beads on the top are on the top upper beads and the lower beads are on the bottom. Okay, so as the second row, as the third one, but the fourth one, there's one bead on the top. The next line, there is one bead at the bottom, that is the heaven one, and the earth one all down, and the earth one on the next line, it has 2 and the upper has none. Okay, so when you look at these, you see that it is 2,51,000. This is how abacus is used to be calculated. Okay, now this is where it was implemented, and it started to we started to use them, and even now we are still using them in the pre-nursery and nursery classes and so on. Okay, now the next one is that Napier bones. John Napier, the Scottish mathematician, developed a manual operated calculating device named as the Napier bones. It was considered to be the world's first calculator that could multiply, divide, and find the square root of the numbers. In 1617, this machine was designed and developed, but later modified to make it more useful. Using the mathematical tables embedded in the rods, multiplication can also be reduced to repeated addition, and division can be reduced to subtraction. So Napier created this particular this particular calculating device, and that's how he created this multiplication. That 7 ones are, this is an example they have given here. So 7 ones are 7, 7 twos are 14, and so on. So this is what is being done. So you can do these calculations, that is of multiplication and division, and even they were able to find the square root of numbers also using this bone, Napier's bone. Okay. Now next is we will be going to Pascal's addition machine. In the year 1642, a French mathematician, Blaise Pascal, developed an addition machine known as Pascal's adding machine or Pascaline. He invented this machine at the age of 19 years. It was the first ever mechanical and automatic calculating machine or calculator. The machine could perform only addition and subtraction. Moreover, multiplication can also be done with the repeated additions. So Pascal was the one who found the the machine which could do two things, which is of mainly of addition and subtraction. It was also be able to do the multiplications as well. That was a good part in this. So Pascal was the first person to find this machine here. Okay, so going further, and when you see who's Pascal, Blaise Pascal is the one. This is Blaise Pascal, and Pascaline is the device which he invented. This is the device he invented. Okay, so next is Leibniz machine. This machine was developed 30 years after Pascal's arithmetical machine. The German mathematician Gottfried Leibniz developed a mechanical calculator in 1673 and named it as stepped reckoner. It was based on the concept of Pascal's adding machine. In 1804, Joseph Marie Jacquard, a French inventor, that is this paragraph. In 1804, Joseph Marie Jacquard, a French inventor, devised a loom that used punched cards to direct the weaving pattern. This could perform all four basic mathematical operations: addition, subtraction, multiplication, and division. It was helpful to perform lengthy calculations. So basically it's all theory here. So as you keep and you need to remember these dates and who invented what. So when you go into the activities, you may require all these informations there. So this is all theory. Alright, so most important person we are going to talk about is Charles Babbage. Charles Babbage was a professor of mathematics in Cambridge University, England. In the year 1822, he designed and developed a machine known as difference engine. This machine could perform most of the mathematical calculations. Okay, So this is Charles Babbage who found this, which could perform all the mathematical calculations. Okay, so after working on different engine for 10 years, Babbage designed another machine named as analytical engine in 1833, which could perform the task based on instructions. He thought to make it as the first general purpose computer. Unfortunately, his analytical engine remained a dream. So basically, he did find an a kind of a computer, but unfortunately he could not complete it. So it was her who actually invented the programming language. So basically all whatever the design which Charles Babbage had, it was Lady Ad Augusta was the first person who designed the programming language. So she is called the first programmer of the universe. Okay, so basically what happened is that when she created this particular programming language, she created it or used binary numbering system, which is of basically zeros and ones. Okay. Okay, so it has been explained here. The lady Ada Lovelace Augusta was one of the disciples of Charles Babbage. She worked on an analytical engine and fulfilled Babbage's dream. It was her contribution that made the computer a programming language or a machine. She developed the concept of binary number system in programming techniques. Hence, she is known as the first programmer of the universe. The computer language ADA was named after her. Alright. Okay. Okay, so we will be learning about generations and development of computers. In 1944, Howard designed a computer named Mark I that was designed by IBM. It was based on the idea of Charles Babbage and was similar to the analytical engine. The size of Mark I computer was like a room and had a complex design with thousands of components. It was the first machine that could automatically perform calculations according to the programmed instructions. Okay, so gradually the hardware and software components developed and passed through many generations. In computer world, the term generation referred to the word change in the technology. Okay, so in every generation, the computer technology became more advanced than the previous one. There was many developments made during each generation, which is discussed in the next page. Alright, so let's look at the next page to understand each of these generations one after the other. Alright, okay, so the first generation was in the year 1940 to 1956. So we need to remember these years. Every generation years also is important, because in your activities you may get these kind of questions. All right, so you have to remember these years are very important. All right, so the first generation computers used vacuum tubes. So this is how the vacuum tube looks like. So this is the vacuum tube they were using, which also caused a huge amount of heat and other problems also, and the size were huge. The amount of space it was occupying was very much more. Okay, so this is explained here. The size of the computer were huge, almost the size of a big room. They used to generate a lot of heat due to the presence of numerous vacuum tubes. Okay, alright, the first generation computers used machine level language. Okay, it means the instructions were given in terms of binary digits. As I told you, a lady at Augusta. She was the one who found the programming language, and she used binary language, which is of zeros and ones. The same was used there. All right. Okay, so the computer were capable of performing one task at a time. So nowadays we have computers which can do multitasking. So any number of applications you use, the computer is doing all kind of job at the same time. So if you are editing, you are opening a Word document, you are opening a PowerPoint presentation, you are opening a game application there, anything, it is doing that. But in the first generation, it could do only one task at a time. Okay, the first generation computers made possible the development of ENIAC by professors J. Pierce Eckert and John Macaulay. Later on, an advanced version of ENIAC was developed with the name UNIVAC. That was world's first commercial computer. So basically in the first generation, it was the vacuum tubes which was used, and it used to create a lot of heat, and used to be very big rooms. And these in the first generation, it was basically the binary digits which was used, that is then machine level language, which is of zeros and ones. And in the first generation, the Professor J. Pierce Eckert and John Macaulay was the first professors who created this or developed these programming languages, made it a little more advanced. Okay, and then later it was named as UNIVAC. Later it was developed, and the world's first commercial computer was created, that is UNIVAC was the first commercial computer it was created. All right, so let's go to the next second generation computers, which is in the year 1956 to 1963. Here they used transistors. These are the transistors they were using, which is replacing of the vacuum tubes, replacing of this vacuum tubes, this one. All right, okay. So the second generation computers used transistors, replacing the vacuum tubes. Okay, so with the invention of transistors, the computers became a little more smaller. Of course, not to the ones which we are using. The vacuum tubes, from the vacuum tubes and big rooms, it was little more compressed size. Okay, the speed of the computers increased from milliseconds to microseconds. During this period, the first operating system was developed. So this is very important. The first operating system was developed to communicate with the computer. Second generation computers used magnetic tubes as a second storage device. Magnetic tapes, I'm sorry, not tubes, tapes as the secondary storage device. During this period, some high level languages like COBOL, that is a common business oriented language, and basic beginners all purpose symbolic instruction code were developed. Some of the computers of the second generation are IBM 1400 and Honeywell 400, etc. Alright, so basically the difference between the first generation and second generation is that in the first generation they used vacuum tubes, in the second generation they used the transistors. The first generation, the size of the rooms were very big. The vacuum tubes were creating a huge amount of heat, and the next thing is that they used a binary language, which is called as the machine level language, which is of zeros and ones. Now the same concept is being used here as well. The only thing is that instead of using the vacuum tubes, in the second generation they started using the transistors, okay, replacing the vacuum tubes. All right, and Yeah, and their sizes were also small, and they were little faster and more reliable also. The possibility of vacuum tubes burning or bursting could be very high. We do not know. Yes, this really helped in the second generation. So as we go to the third generation, it became little more better. So we'll go into the third generation to understand what actually more changes were done. Okay, so in the third generation, that is in 1964 to 1971, the concept of integrated circuit, that is ICs, made a major breakthrough to improve the quality as well as the performance of the computers. The integrated circuit is the compact electronic circuit containing hundreds of transistors and other electronic components. Okay, so as I told you, yes, from the first generation to the second generation to the third generation made a huge change, huge impact, and the improvement of the quality was very, very, very good. All right, so let's see furthermore, um, which which are packed on tiny pieces of semiconductor materials known as IC chips. This generation made possible the invention of mainframe computers. So the mainframe computers, as we go to the next chapters and so on, you will understand more about that. Okay, so let's go to the fourth generation. In the fourth generation, that was in the year 1971 to 1985. In the year 1975, an integrated circuit, that is IC, was developed which could hold thousands of transistors in a single component. This technique was known as large scale integrated LSI circuits. The component was called as integrated circuit. Yes, but again it was able to hold thousands of transistors. In the second generation we used transistors. In the third generation, yes, we used to an amount, but there were couple of the transistors. But in the fourth generation we used one kind of a transistor, and that is one single transistor, and all the components were put inside that particular transistor. Okay, so that is your Intel core, this one. Okay, so currently we are still using this Intel. Okay, and the concept of microprocessor came into existence with this generation, which led to the development of microcomputer. However, in today's world, Intel Core series of considered to be one of the most powerful microprocessors developed by the Intel Corporation, USA. All personal computer PC manufactured by IBM, Apple, Dell, Compaq, Lenovo, etc. belong to the fourth generation computers. Okay, so the currently whatever the computers we are using here, we are using Intel Core, this particular Intel Core. So this is the one even till today we are using. We are not gone to the fifth generation yet, to be very, very, very precise. The fifth generation is an artificial intelligence. Yes, people are creating and few robots which can do certain things but not everything. It cannot understand feelings, or it cannot understand what we want. We have to instruct it to do that job. So if we say get that particular pencil or a pen, you have to write some codes for that robot. Okay, so we have not gone into that fifth generation still. Okay, but the process is still there going on. So as of now, from 1985, from this 1985, we are still in the fourth generation. Okay, so now next thing is that fifth generation. The fifth generation computers are based on artificial intelligence. The main objective of the fifth generation is to develop a device that could respond in a natural way. As I told you, the natural way these robots cannot understand. These robots cannot understand anything unless you have particular instructions given to them. So they cannot do. So they are still trying out, people are still trying out, all the scientists are still working on it anyways. So let's go furthermore. So it will be capable of thinking, learning, and will have the power of human intelligence. These computers have the following characteristics: they have artificial intelligence, they are able to recognize image and graphs, they can take a decision and have a logical reasoning. Yeah, yes, but still it's in the process, it's not yet completed. Anyways, so example, coming to the next, they have given the examples here in the fifth generation. So let's look at the example here. Yes. Okay, so intelligent robots are programmed to carry out certain tasks. So they decide themselves as how the task should be accomplished. So yes, that has been told. As I told you, it is still not accomplished. The scientists are still working on this particular task itself. Okay, so now we will be discussing about the characteristics of a computer. A computer is an electronic data processing machine that accepts data and instructions through an input unit. It processes data into meaningful information in the desired form. The computer has a number of characteristics. Some of them are explained below. Okay, so before that, let us understand what is the characteristics of a computer. That is, what is basically a question like, what is a computer? A computer is an electronic device which accepts data and processes that particular information, and then once it processes the information and through an input device, and then sends that particular information to an output device. So the input device which I'm talking about is the keyboard, mouse, monitor, keyboard, mouse, joystick, microphone. Any of these is an input device. So when you give some instruction, this instruction goes into this particular processor. Okay, so this processor takes all the information, processes the information, and then sends it to the memory, and then gives that information to the output device, which is your monitor or a printer or any of those devices there. Okay, so that is the characteristics of a computer. Now, what all does it have? What are the features does it have? A computer can perform calculations at a very fast speed. It can perform thousands of mathematical operations in a fraction of a second. So it is so fast that you don't need to wait for it, it just gives you the output immediately. That is the speed of the computer. They are very fast. Next is the accuracy of the computer. So how accurate they can provide you information. Computer systems are highly accurate electronic device. It performs each and every calculation with the same accuracy. Generally there is no ambiguity in the results produced by the computer. An error may occur due to a technical problem or feeding incorrect data. So if you are giving some information which is wrong or not an accurate information, then it gives you an error. But otherwise it gives you an accurate information. For that matter, if you're trying to use any applications, it can be of calculator, or it can be of a word document. You're opening a word document and it does a particular job. It opens that particular application immediately. It doesn't open some other application when you're trying to open some one particular thing which you want. It doesn't do that. It is very accurate. When you want to open Internet Explorer, it opens Internet Explorer only. Alright, so they are very accurate and give you the accurate information. That's the best part in this computer. Next is the storage. A computer has a memory that stores all the data and information. The data remains in the memory of the system unless it is deleted. The storage of data can be temporarily or permanently in nature. The data storage capacity is measured by bytes, kilobytes, megabytes, and terabytes. So as we go further and further regarding the kilobytes, megabytes, terabytes, those informations will be given in detail. Okay, so as far as the storage is concerned, it stores the information, and when you want the information, it just takes it out from the storage device and then gives it to you. So the storage can be of your hard drive, it can be of a USB pen drive, it can be of a CD-ROM drive. Okay, so it just takes out the information and gives it to you accurately. Okay, next is diligence. A computer, unlike humans, does not get tired. It can work continuously for hours without any error. It will maintain the same accuracy and speed even after millions of calculations. So it does not we if you give us a calculation and then the next person tries to do a calculation, the person gets tired after a couple of minutes. But as a computer, it does not get tired at all. It never gets tired. It doesn't make any errors. It doesn't give you any mistakes while you're doing so many multiple things or multitasking, or multiple applications are running at the same time. So since the other application is running, it doesn't give an error in this particular application. It doesn't do that. It does an accurate job in all the applications. Okay, right. Next one is versatility. So that is, a computer is a multi-purpose machine which can perform variety of tasks. So as I told you, if you are trying to open multiple applications and it is doing one particular application, Internet Explorer is running, and you're opening a Google and you're trying to open another application which is a word processor, and you're trying to type some documents while Google is running there at the background, it doesn't get any kind of an error message, and it can do multitasking. So you can open any number of applications at the same time and work on it. So here they have given example. Using the same computer, an accountant can prepare a balance sheet and an architect can design pictures or drawings. Moreover, it can be used to make animations and presentations, to play computer games, to send emails or shop online, etc. This makes computer a versatile machine, which means you can do any number of tasks with a single computer. You don't need to do or you don't need to have multiple computers to do different tasks. You can have one single computer, but you can do plenty of tasks in the same computer at the same time. That is the speciality of the computer. All right, now next is the limitations of a computer. Though a computer is a super machine and performs better than a human being, it has some limitations. So the first limitation is computer cannot decide, and computer cannot think, and computer cannot express ideas. So you give a particular task, it cannot decide itself. Okay, so you're asking here they have given an example which is like 2% age as 25 and minus 15. It cannot understand. And if you are saying which is the smallest number, so one person is 25 years and the other person is minus 15 years. Minus 15 years is, there is no possibility of a minus 15 years. Can be 15 years. Okay, but computer cannot decide. It can only decide which is a small number, that is all. But minus 15 and 15, it cannot judge on it. Okay, so the same way it cannot think. So when you are giving a task, it will do only that particular task. It cannot do other tasks unless it is being asked for. Or when you try to open a particular application, or when you want a word process to be opened, it will not do it. You have to go and open that particular application, only then it can do that particular task. Next is computer cannot express ideas. In today's world, many research work is taking place by the scientists in the research center. They always share their ideas among themselves to come to a conclusion. In the context, computer cannot express their ideas. So they again a different way of expression, but basically you have an idea, you can share that idea and make the computer to do that, but computer itself doesn't have an idea. What you want is what you can get it out from a computer. So if you are expecting a result from a computer, it cannot do that. Or if you are asking some kind of an information, it cannot do that. All right, so that is the limitation a computer has. So now quickly let's go at a glance about the generation, period, technical use, size and speed, language development, cost of the machine, storage capacity, etc. Okay, so it's a quick review we are going through. So let's go through the first generation. First generation, the period was 1942 to 1954, and the technology used was vacuum tubes. The size and speed was very large and slow also, and the language developed was machine and assembly level languages. The cost of the machine was very high, and the storage capacity very less, RAM and secondary storage. Okay, the second generation is 1954 to 1959. At the time, technology used was transistors. Speed and size was comprehensively smaller, and speed is increased. Language developed, operating system and higher level languages came into existence. That was the time where the operating system came into existence. The cost of the machine cost reduced than the first generation of computers. Capacity of RAM and storage increased slowly. Third generation period was 1959 to 1971, and technology used was integrated circuits. And the speed and size reduced and the speed further increased. Language developed, high level language developed like RPG and ALGOL. Cost of the machine further reduced in the cost. Storage capacity, RAM and secondary storage capacity increased further. Fourth generation, it is 1971 to 1980. Technology used was microprocessor. Speed further reduced and desktop computers introduced. Language developed, further high level languages developed like C++ and Java. Cost of the machine reduced, cost which drastically went down. Okay, and the storage capacity, RAM and secondary storage increased further. The size of the storage became more and more. Okay, which was in MB, megabytes. And then in the fifth generation, which is of 1980 onwards, technology used is artificial intelligence. Size and speed, portable computer came into existence. A language developed, HLL, with the knowledge information processing system. Cost of the machine reduced, cost. Storage capacity, RAM in GB and secondary storage in tera and petabytes. Okay, so as we see it here. Okay, here, all right, petabytes. So this is a quick glance about the computer, that is from the first generation to the fifth generation. So we have, as of now, we have completed this particular chapter. Now on the next video we will be doing this particular exercise. On the next video we will be doing this particular exercise with all the answers written in a different book or a paper. Alright, so get ready for the next video, and thank you very much for watching. Thank you.